Okay, good morning everyone. The second day of class. I'll go over some of the problems you had for homework that students had questions on, because if one or two students had a question, then you may have had a question as well. So I'll take a look at three problems and I have them highlighted. Number 15, x not equal to 5. So x not equal to 5. If I were to draw the number line for that, it will look something like this here. So here would be 0, and here would be 5, and x would be any value except 5, so we don't include 5. So it's open at 5, but it goes to positive infinity and it goes to negative infinity. Okay, so that's what the number line will look like. They didn't want you to draw a number line, they wanted you to write that in interval notation. Okay, so the way you would write that in interval notation, okay, for this side of the number line here, well, that would just be from negative infinity to 5. And it would be open at 5 because we're not including at 5. And then on the other side, it would be, so we would have an or, so it would be open at 5 because we're not including 5, and it would go to positive infinity. Okay, so that's the way you would write that for number 15. Number 18, they wanted you to write that in words. Okay, so we're including 3. So again, if I just draw the number line for that, okay, so we would be at, so this would be, I always like to use 0, so 0, 3, and we'd start at 3 and go all the way to negative infinity, and then we would be at 5, and here would be 11. We'd be open at 5 and closed at 11. Okay, so in words that would be numbers less than or equal to 3. Okay, so that would take care of this here, numbers less than or equal to 3. And then on the other side it would be or numbers greater than 5 and less than or equal to 11. Okay, so that would take care of that side. Numbers greater than 5 and less than or equal to 11. So that would be in words. And then number 20, well, they've already given you the number line. It would be like number 18. It would be numbers less than 3, because we're not including 3, less than 3. So that would be that side of the number line. Or numbers greater than 0 and numbers greater than 0. Okay, and that would take care of that side of the number line. All right, so I hope that helps. So a couple of students had questions on those 3, so I just wanted to go over them. All right, and so we're going to be going to the next 2 lessons. We have 2 lessons today, and we'll be working with 1.6 and 1.7. 1.6 is relations and functions. Okay, it's the beginning of what Algebra 2 is all about. Knowing everything about all the functions we'll learn in class this year. And then we'll use function notation in 1.7. Okay, so today the objective, we need to identify what do we mean by domain and range of relations, determine whether a relation is a function, And then we'll have the vocabulary terms: relation, domain, range, and function. But right offhand, let's think about this relation. What is a relation? Well, okay, so we have a relation. Okay, so imagine mom and your mom and dad, if they're married, okay, they're in a relation. All right, and we're going to say it's a good relation because your mom only has one husband, and your own husband only has one mom. So that relation is a good relation, and good relations like that are called functions. All right, and so you could have a bad relation where like a guy may be dating two girls. Well, that's bad. Okay, it's still a relation between a guy, but now and two girls. So it's relation, but that would be a bad relation, and we'll see that's not a function. So when we have a relation that's a good relation, we say that's a function, okay? We like those, okay? They keep people happy, all right? So here, let's take a look at what a relation is. A relation is a pairing of input values with output values, like mom with dad and dad with mom. It could be shown as a set of ordered pairs, x and y, where x is the input and y is the output. So it's a pairing of input values with output values. And the set of input values of a relation is called the domain. And the set of output values is called the range. Okay, so x is the input and y is the output. The domain is the input. The range is the output. So one easy way to remember domain and range: x comes before y, domain comes before, or d comes before r, domain. Okay, so the domain, okay, involves the x's, and the range involves the y's. X comes before y, d comes before r. It's a very easy way to remember that. All right, so let's look at a mapping of a relation. Okay, so this tube, well, it goes to A and it goes to B and it goes to C. Imagine if 2 was mom, and mom had 3 husbands, A, B, and C. It may be a relation, but that would be a bad relation, and we'll say, hey, okay, that relation would not be a function. It would be a bad relation because we have the x going to multiple y's. All right, 2 goes to A, 2 goes to B, and 2 goes to C. Now we can write that as an ordered pair. Okay, so using roster notation, we have an ordered pair. Okay, 2 goes to A, 2 goes to B, and 2 goes to C. Okay, that is a relation. So as I mentioned up here, as I mentioned there, x is the input, y is the output, x is the domain, y is the range. Okay? X is the domain, y is the range. Example, identifying domain and range. So here we have some ordered pairs. We have 5 ordered pairs. Okay, and so for each ordered pair, we have the x and the y, 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 the x and the y. So let's list the ordered pairs. Well, I don't know why they asked to do that. They're already listed. But the domain, remember, are the x's. So we have 100, we have 100, we have 120, we have 140, we have 160, and then we have 180. Okay, so that's the domain of that relation. And the range are the y's. So we have 5. We have 5 again, but we don't list that. Okay, we don't duplicate the same y. We have, see, that's a 5. So we don't list 5 twice in roster notation. And then we have the 6. And again, 6 occurs twice, but we only listed once. And then we have the 12. So the domain would be the 100, 120, 140, 160, 180, and the range would be 5, 6, and 12. So let's look at this graph of ordered pairs and identify the domain in the range. So this is the point negative 2, 2, right? So that's the point negative 2, 2. That's that point there. And then this is the point negative 1, 1. So that's that point there. And this is the point 0, 0. And then you can see the other points. We have 1, negative 1, 2, negative 2, and then 3, negative 3. All right, so we have a relation. We have a relation. So the domain, again, there are the x's. The x's, we have negative 2. And when we list the domain or the range, we always start with the smallest x and go up to the largest, okay? All right, we always start with the smallest and go up to the largest. And so negative 2, and then negative 1, 0 and 0, 1 and 1, 2 and 2, and 3 and 3. So that's the domain. Those are the x's. And then the range, we have the 2. Now notice here, it's listed there because we're going to write this from smallest to largest. Okay, and then we have the 1, and then the 1, and the 0, and the 0, negative 1, negative 1, negative 2, negative 2, negative 3, negative 3. So the preferred method in writing the domain and range and roster notation is always to write from smallest to largest. Okay, even though in this example up there, the y's, okay, for the ordered pairs, they weren't listed from smallest to largest. It's good practice to write your domain and range and roster notation from smallest to largest. Okay? All right, so a relation in which the first coordinate is never repeated is called a function. In a function, there is only one output for each input. So each element of the domain is mapped to exactly one element in the range. That's a good relation. Okay? Each x only goes to one y. Each x only goes to one y. Okay? Although a single input in a function cannot be mapped to more than one output. Although a single input in a function cannot be mapped to more than one output, two or more different inputs can be mapped to the same output. So let's take a look at this. So here we have 2. That's my x, and that's my range is y. So 2 goes to A. If I were to write that as an ordered pair, 2 goes to A, and then 2 goes to B, and then 2 goes to C. Now notice here, the one input 2 goes to multiple outputs. It may be a relation, but it's a bad relationship. It's a bad relation. It's like a guy dating 3 girls. Okay? That's a bad relation. So that's not a function. It's not a function. All right? But here, we can have multiple y's going to the same x. Okay? It's a relation and it's a function. All right? So if I have to write that, we have A that goes to 2. We have B that goes to 2. And then we have C that goes to 2. Notice each input, each x only goes to one y. A goes to 2, and A doesn't go to any other thing. B goes to 2, B doesn't go to any other thing. And C goes to 2. C doesn't go to any other thing. Okay? And so relations where each input only goes to one output is good. Okay? In mathematics, it's good. Okay, imagine this. So imagine that the domain here was 2. So imagine that was like U. And then let's say here the A, B, and C were birthdays. Okay, that would be kind of strange for you to have multiple birthdays, right? That just wouldn't make sense. You would have multiple birthdays. That just wouldn't make sense. But let's say here, rather than, so in the other example, let's say A, B, and C were different students in a classroom. Could different students in the classroom have the same birthday? You bet. Okay? Different students could have the same birthday. That would make sense. It's a relation, and it's a good relation. It's something that makes sense. All right? All right, so we'll continue on here. Determine whether a relation is a function. So from the items, oh boy, that drives me crazy. From the items in a store to their prices on a certain date. There is only one price for each different item, okay? You go in the store, mom and dad goes in the store and they buy a box of Cheerio. When they go to take it to the cash register, you hope there's only one price. Okay, so that's a relation. That's a function. That's a function. Now, from types of fruits to their colors. Well, you could have an apple. You could have an apple, and it could be a red apple. It could be a red apple. It could be a green apple. And you can have a green apple. Okay, you can have a yellow apple. Okay, a yellow apple. All right. So an apple goes to red, an apple goes to green, and an apple goes to yellow. Well, that's not a function because that apple goes to red. Apple goes to green. So it would be like a apple goes to red, and then apple goes to green, and then apple goes to yellow. So you see that the X goes to multiple Y's. All right. Determine whether each relation is a function from size, shoe size to price. So 7 goes to 35. If I list that, 7 goes to 35. And then 8 goes to 35. And then 9 goes to 35. That's a relation. That's a function, I mean, because each X only goes to one Y. And again, the same Y can go to multiple X's. The same Y can go to multiple X's. But each X must only go to one Y, so that's a function. From the number of items in a grocery cart to the total cost in the grocery cart. The number of items in a grocery cart would be associated with many different total costs of items in the cart. The relation of the number of items in a grocery cart to the total cost of the items is not a function. Okay, so yeah, mom or dad may go in the store and they have 10 items in the grocery cart, right? Okay, so that's on one day. They have 10 items in the grocery cart. Okay, they have some items. Oops. All right, and so maybe that grocery cart has like $50 worth of items. They have 10 items in that grocery cart. And then you go to the store the next week and they buy another 10 items. Another 10 items. And maybe now the total cost is $75. So if you were to look at it, you would have 10, which is the input, goes to 50 on one week, and then 10, which is the number of items, goes to 75 on another week. So that is not a function. That X, 1X, goes to multiple costs. That's not a function. All right. So here. Now, okay, every point on a vertical line has the same x-coordinate. So vertical line, so for example, if I draw a vertical line, every point on a vertical line has the same x-coordinate, okay? So let's say here, so that's x. Well, I'm going to kind of like draw this in terms of a graph, if you guys remember. So x and y. So this is x. So let's just say that's one of the x values. But every line has the same x coordinate. Every vertical line has the same x coordinate. All right, even though the y values may be different. So, okay, like this may be the value 5, and this may be the value 10, and this may be the value 15. But let's say here the value for this x was 5. The value for that x was 5. So we could list that as an order pair. 5 goes to 5. 5 goes to 10. And then 5 goes to 15. Okay, and you'll see that is not a function, okay, because we have one x that goes to multiple y's. If a vertical line passes through more than one point on the graph of relation, the relation must have more than one point with the same x coordinate. Therefore, the relation is not a function. I just showed that. Okay, you can take a look at that. That is not a function. That's all this was saying. So it's a very easy way to look at a graph and determine if the relation is a function. All you have to do is draw a vertical line through that graph. So for example, here we have a graph. Is that a function? You bet. Because if I draw a vertical line at any point on that graph, any point, it only has one y value. It only has one. If any vertical line I draw, it only has one y value. That is a function. So you can look at a graph and determine whether or not the relation is a function. If any vertical line only has one y value on the graph, then it's a function. Now let's take a look at this one here. Okay, so I can draw a vertical line, but notice that has two y values. So that could be some. So let's see here, that y value, let's say here that was 3, and this y value was -3, and the x value here, let's say here this x value was 2. So that would be like 2 goes to 3, but then 2 also goes to -3. That's not a function. All right, so it's very easy to determine, okay, by looking at a graph, if the relation is a function. If it passes the vertical line test, which means that there's only one y value on that vertical line, then it's a function. So 3a, using the vertical line test to determine whether a relation is a function. If not, identify 2 points a vertical line would pass through. As you can see, if I draw a vertical line through any point on that graph, it's only going to have one y value, only one. Okay, so it's that relation is a function. That relation is a function. Let's look at the next one. All right, so if I draw a vertical line anywhere, notice here, that has 2 y values. Okay, so that would be like -3. So this is a point like negative right here. That would be like -3 and 1, and this would be like -3 and 4. Okay, that would not be a function. A vertical line in x is equal to 1, for example, they gave you that, would pass through 1 and -2. Yep, so there's -2 there, and there's 1. It fails the vertical line test. It is not a function. And then use a vertical line test to determine it would be a function. Okay, I can draw a vertical line, and it would only have one y value. And again, would this be a function? Well, if I did this here, well, okay, it only has one value, one y value. But if I did this here, notice that x, it has 2 y values. So that would be, so this here would be the point like 1, x is 1 and y is 2. And this here would be the point like x is 1 and y is -2. Okay? It's not a function, not a function. Okay, I think maybe for homework you'll have something like this here though. It may be, let me erase this here because this is always a good problem. So let's say rather than this being closed, it was open. Okay, which means it doesn't include 2. Okay, that line, so let's say here that line doesn't include 2. All right, so there, yeah, so that would be a function because if I draw a vertical line, okay, so this would be x any number less than 2, but here this would be any number 2 and greater. All right, so that would be a function. All right, and let's see here. So here we have the lesson quiz. So I want you to do that. Identify the domain and the range. What's the x and what's the y? Write it in raster notation like I've done. The domain, what are the x's? And the range, what are the y's? And determine whether each relation is a function. From each person in a class, the number of pets he or she has, from city to zip code, and then number 4. Okay, so that's that lesson. That's section 1.6. So I'll have another video for section 1.7. As I said, okay, we move pretty fast, so I have to give another lesson here.